Well, today's the day before Inauguration Day, and we've been having a bunch of fun problems with the transmitter. Last video made, we had the thing on the dummy load, and it was making normal power and was modulating okay. Right after we made that video, this modulator tube right here got red hot and started arcing inside. And the transmitter wouldn't load up right, and blew the fuse in the variac, and of course I wasn't happy, and a lot of stuff has happened since then. I had thought that perhaps that I had blown up the modulation transformer here. Although I didn't. The modulation transformer did not smell, it did not get hot, and it did not make any smoke. So I took the tubes out. I tested the modulation transformer. I guess I tried to test it with the tubes in the sockets, and that was a big mistake, because I think this tube right here had arced over, and I was getting all kinds of crazy readings, and I thought my modulation transformer was blown up, and went looking around for my spare, and I couldn't find it, and I thought I sold it, and I was depressed. But I took the modulator tubes out and I tested them, and I went through the same procedure we went through earlier, measuring all the resistances of the primary and secondary of the modulation transformer, and also measuring between the primary and secondary for shorts. There should be no connection between the two, and measuring to ground. And I measured the center tap of the secondary and got 32 or 3,000 ohms, and I thought, oh dear, there's the problem. What I was really looking at was the bleeder resistance from the power supply. When I lifted that wire to the well, I guess it's the center tap of the primary of the modulation transformer. When I lifted that, then all of the readings were normal. There were no shorts to ground. Everything was perfect. And in the meantime, I found my spare Valiant modulation transformer, and it measured exactly the same as this one. And they both agreed with what's in the book. So we dodged a bullet on that one. So I tested all my tubes, and I decided that I would put a good pair of used tubes in here. They're not terribly well balanced, but they're pretty good. But I thought if there's another event, I'm not risking my best tubes. So then I went back to recheck the bias supply, and I thought that I had bent the tube pins on that 6BY5 bias rectifier, and that it was going to be reliable, but it was intermittent, and that was what happened. Was when the modulator tubes lost their bias, they just went crazy. Tube got really hot. I guess the elements inside just stored it. It arced over, all kinds of nasty crap, and of course the final amplifier lost its bias too. So I dug around in my tube box, and I had another 6BY5. It's even got the Johnson logo on it, so we know where that came from. That's a used tube out of another transmitter, but it's fine, and it doesn't go intermittent no matter how you wiggle it. I think I may take that other tube and try to resolder the tube pins on it or something and see if that makes it work right. But anyway, we seem, I think, to have a reliable bias supply here now. So I went through and reset the bias for the final amplifier and the modulator. And lo and behold, now the idle current for the modulator has come down from 120 milliamps to 70. It's supposed to be 60. But I know what the problem is. Each of these bias pots has a fixed wire wound resistor associated with it. And one of them is 9K and one of them is 12 or 15K. And they put them in wrong. The fixed resistor that's supposed to be on the mod pot is on the RF bias pot and vice versa. So that's why we can't get quite the right bias for the modulator, but when I swap those resistors, it'll swing around and we'll be okay. But anyway, I was able to use it on the W load, and 70 milliamps of resting current is very close to what it should be. And it worked right, it sounded right, much better than it sounded before. And so we're on the right track. So I thought, well, okay, gee, everything ought to be groovy now. All we got to do is neutralize it and we'll be home free, right? No. While I'm testing the thing on the dummy load again, I start smelling something hot. And I stick my nose around here and I find out that this drive control is so hot you can barely touch it. Well, it's a 4-watt wire wound, and it might run a little warm, but it shouldn't get really hot. And it stank. And I measured it in the circuit, and it measured 20,000 ohms. Well, the book says it's supposed to be 25,000 ohms, so it's 25% off on the low side. And so that bothered me, and I said, well, I'm going to take it out of the circuit and I'm going to test the wiring that goes from the pot to the screen of the multiplier driver to make sure there's no short or anything in there, and that's got infinite resistance to ground. And then I'm looking in the schematic trying to find the bleeder resistors for the low voltage power supply. And if you look on the schematic here where this blue line is, you'll see that there's a 15K 10-watt resistor and a 18K 2-watt resistor, and they make a voltage divider, and goes off from there over to the regulator tubes for the modulator and plate screen supply. But that is the bleeder resistor for the low voltage supply. So that's supposed to bleed the filter caps and also stabilize the low voltage so it doesn't soar. Well, you can follow the low B plus around, and eventually you get over to, here it is, to the drive control pot. So there's the full low B plus is on that pot, and it goes straight to ground. So that's like another little bleeder resistor right there. So if it's 20K to ground, straight to ground with 300 volts on it, straight to ground, instead of 25K, it's going to get hotter. So I took the pot out and said, I want to see if it's damaged. I want to see if it's burned up. I want to see if some of these coils are shorted, and that's why the resistance is lower. And I couldn't, it was full of grease. I think, you know, it should have a little bit of grease on the shaft here, but the whole inside had globs of grease, and this phenolic, it's gotten so hot that this phenolic has burned, and it still smells like a burn control. I've flushed it out with electronic component cleaner a couple of times, wiped it out with paper towels, sprayed it with deoxit, gotten in there with my little screwdriver and paper towel and gotten all the crud out of it, and it works nice and smooth, and I can't see any damaged turns on the resistor at all. But it's just the value is too low. So I'm not sure what is making this. Either there's something wrong with the this is the drive control, which controls the screen voltage for the 5763. They call it the multiplier, but it's also the driver. Output from that goes straight to the grids of the 6146s. So it goes oscillator, buffer, multiplier, driver, finals. And the way you control a drive is you vary the screen voltage on this 5763 multiplier tube. Well, it's, you know, 300 volts comes to the pot, slider on the pot goes to the screen, and unless there's something really wrong with that tube, like maybe the suppressor grid is shorted to it, or this cap between the suppressor and the screen is shorted or something, it shouldn't draw excess current. What I'm going to do now is I'm going to put this thing back together, and I'm going to turn on the transmitter without the multiplier tube in it, so there should be no load on this resistor, because this is not supplying any screen voltage. And see if the pot gets hot. Should not get warm at all. And then I'm going to plug in the 5763 tube so that it's drawing some screen current, and see if this thing still gets hot. And if it does, I guess I'll try substituting another 5763, because I've tested it on the tube tester and it tests fine. And if that doesn't do it, I'm going to have to start looking for a problem somewhere. I just can't imagine what it would be, but something is causing that excess current to be drawn through the pot. I can't find any fault in the pot. The pot doesn't have a short to ground or anything like that. Works smoothly, not burned up, so something is drawing excess current through it. So this is what we're dealing with now. Once I get this fixed again, I'm going to go back and reset all of the fixed presets on the transmitter, and I'll make a video of it. You set the clamper, you set the keyer, you set the mod bias, you set the PA bias, and you set the neutralization. I'm going to do the neutralization here before I make another video. It's pretty close, but not quite right. So there, this is what happens. Remember the famous fault sheet? All the stuff that we worked down, all the stuff that we fixed and checked before we put power on it and started working. Well, guess what? Here's a new fault list, and stuff we're finding once we fire it up and start trying to make power with it. So we have the intermittent bias oscillator. I think we've got that fixed. The arcing modulator tube, we found out what caused that and got it fixed. We tested it, modulates. but now we've got the drive pot overheating. You know, this transmitter ran and it stayed plugged in, I think, for 6 or 8 hours one day, and it was making screen voltage for the multiplier all that time, and that pot didn't get hot. So something has happened here, and we just don't know what yet. So I decided that if I test the pot with no load on it and it gets hot, I'm going to stick a wire wound resistor, about a 5 or 10 watt wire wound resistor, in series with the B+ lead going to the pot to knock that voltage down and let that dissipate at least half of the power that's being dissipated in the pot right now. That should cool it off and make it still work if we can't figure out anything else. Well, this is one of the goofiest things I've ever done. I'm taking the B+ that's supposed to go through this pot, and I got 3 resistors in series here. So I started out with 7,000 ohms. I added, I don't know, 3,000 or 3,500, and then I added another 3,000 or 3,500. So I guess I got 12 or 14,000 ohms there in series with this pot, which is 20,000 ohms. So we got about 33,000 ohms or something total, and that's gotten the voltage on this pot down from 370 volts to I forget what it is, 209. And the screen wants to see something between 50 and 170 ohms, so that'll work. But I had to add all of that resistance in series here to keep the temperature of this thing down. It's still getting warm. Now, it's a wire wound power pot, so I guess it's supposed to get warm somewhat. There's the hottest pot right there. I can put my finger on it. It's kind of painful. About the most you can stand is about 140 degrees, and that's pretty darn close. I could get my infrared thermometer, but that's pretty darn close to what that's getting. I can't figure out why this is happening. It does it even when this red lead in the middle is the screen lead, and even when you disconnect that pot still gets hot. There's no load on it at all. It's just across the power supply to ground. And maybe there's some defect in the pot that I can't find. I can't find it with no meter. And something is making that thing get hot. So I'm going to have to get about 12,500 ohms, half of the rated capacity of that thing, and put it in series with this stupid thing, keep it from burning up. I'm going to put the tube back in it, put some load on it, see what that does. So here we are. Got the driver working. About the right amount of drive. And got one 15K resistor in series with this wire wound pot. Been running here for about 15 minutes now, and you can put your finger on it. It's warm, but I think that's normal, but it's not hot. This little resistor, I wish this was a bigger resistor. It's getting pretty hot, so it's dissipating about half of that power, and that's what we wanted. Under load, the voltage here before the resistor is 250 volts basically, and after the resistor it's down to 196. If you unkey this thing so the driver's not working, it goes up to 203 from 196, so that's 7 volts change. So there we go. I'm going to let this thing sit in the way that it would be if it wasn't keyed, and see what happens. But that's so weird, I can't account for why this is happening. It didn't get that hot before, and I don't know why. At least I would have smelled it. I mean, the reason I noticed it is because I smelled it. Nothing ever smelled hot in this transmitter before. So, and we found that it did it even with the screen disconnected. Didn't even have this red wire that goes to the screen of the driver tube connected at all. Just had the pot in there, and it got hot. So I don't know, it may be some kind of weird fault in the pot that I can't find with an ohm meter. May eventually cremate itself, but for the moment I think we're limiting the current through it to about well, half or 2/3 of what it was. Gone from 370 volts applied to it to basically 200. So whatever that is, 170 out of 370. Half of 370 is 180. We're dropping. It's just a little less than half. So I guess if this was a 20K resistor, it would be half. But it's pretty close. It's enough. And I measured the volts on the screen with the thing at the proper amount of grid drive. It was about 65 volts. And we can go all the way up to almost 200. So the tube will operate the same as it always did. It won't know the difference. And did I do this without electrocuting myself? You know, even in the warmest place, it's not too hot, maybe 130 degrees or something. So I think that's pretty normal for a thing like that. So that was our weird day's work. Well, there's the final fix. This got this resistor here. It's kind of conduction cooled, tucked in there, and the pot's running cool enough to use. So drive is all normal. I guess we did what we did.